Incredible. The world is once again captivated by another remarkable Starship flight this year. Flight 6 has just taken place, delivering unexpected progress and surprising changes, while continuing to astound with its groundbreaking achievements. With so much to unpack, the possibilities ahead are more exciting than ever. How did this historic flight unfold? What new developments can we anticipate? Let's dive into all of this in today's episode of Great SpaceX. Flight 6, featuring its special passenger Mr. Banana, exceeded expectations with its impressive advancements. This time, rather than attempting to catch the Super Heavy booster, SpaceX opted for a controlled vertical landing in the Gulf of Mexico. Meanwhile, the Starship spacecraft, equipped with pre-flight modifications, successfully relit its engine in space, endured a harsh re-entry process despite the removal of some heat shield tiles, and executed a controlled vertical landing with improved intactness compared to previous attempts. The unexpected decision not to catch the booster has sparked ongoing discussion. Some suggest the issue stemmed from the launch tower and orbital launch mount citing a tilted signal pole atop the tower, possibly damaged during Starship's liftoff. Others argue the booster itself may have encountered challenges, although its performance during the flight appeared flawless. Clues from the live broadcast host's commentary at T plus 4 minutes 32 seconds to T plus 4 minutes and 53 seconds hinted at a potential issue.
That means that we are no-go for the catch. As we said before, both the tower and the vehicle, as well as the operators on console, have been actively evaluating the commit criteria for that return to the launch tower. And unfortunately, we did not have a pass on those commit criteria, so we are no-go for tower catch.
However, the more likely explanation points to complications with the launch pad, which could have impacted the connection between the booster and the tower, making the catch attempt too risky. Prioritizing safety, SpaceX opted for a controlled splashdown instead. Fortunately, SpaceX provided an update clarifying that the abort was triggered by the tower after an automated health check of critical systems. This indicated that the issue was likely related to the communication system at the top of the tower, while the booster itself performed fine throughout the flight. Despite these adjustments, SpaceX once again achieved the monumental feat of landing both stages, paving the way for the company's ultimate goal of full reusability. The milestone drew reactions from several prominent figures. Newly elected President Donald Trump, who attended the launch, shared his excitement beforehand. "I'm heading to the great state of Texas to watch the launch of the largest object to ever be elevated, not only to space, but simply by lifting off the ground. Good luck to Elon Musk and the great patriots involved in this incredible project." NASA Administrator Bill Nelson also applauded this achievement, stating, "Congrats to SpaceX on Starship's 6th test flight. Exciting to see the Raptor engine restart in space. Major progress towards orbital flight. Starship's success is Artemis's success. Together, we will return humanity to the moon and set our sights on Mars." Elon Musk, SpaceX's CEO, expressed his enthusiasm on social media. "Successful ocean landing of Starship. We will do one more ocean landing of the ship. If that goes well, then SpaceX will attempt to catch the ship with the tower." SpaceX President Shotwell commended the team's efforts, SpaceX teams continuing to make the nearly impossible look easy. And Jarrett Isaacman, leader of the Polaris program, added, "Congrats, SpaceX. Soon we go back and then on to the Red Planet." With each test flight, SpaceX moves closer to achieving the ambitious goal of full-stage reusability, a critical step toward revolutionizing space exploration and making humanity multiplanetary. But you and I... we both know what you really came here for. So here's how the flight unfolded step by step. Fuel loading commenced approximately 50 minutes before liftoff and was completed 3 minutes prior to launch. 10 seconds before liftoff, the water deluge system activated to mitigate heat and pressure generated by the engines. Then, just 3 seconds before liftoff, all 33 Raptor engines ignited flawlessly, propelling Starship skyward once more. The spacecraft reached max Q, otherwise known as the point of maximum aerodynamic pressure, just over a minute into the flight. At T plus 2 minutes 34 seconds, the 30 outer and middle ring engines of the Super Heavy booster shut down to facilitate stage separation. From that moment, the two stages embarked on their respective trajectories. For Super Heavy, the 10 middle engines initiated a boost back burn at T plus 2 minutes and 45 seconds, by T plus 3 minutes and 27 seconds, and T plus 3 minutes and 35 seconds, the middle and inner engines had shut down in sequence, and at T plus 3 minutes and 58 seconds, the hot staging hardware was jettisoned. This time, the booster did not attempt a tower landing, but instead descended towards the Gulf of Mexico. At T plus 6 minutes and 37 seconds, 13 engines reignited to prepare for splashdown, with only 3 inner engines active at T plus 6 minutes and 42 seconds as it approached the water. Fascinatingly, the booster stood upright on the water's surface briefly before toppling into the ocean, followed by a large explosion. Unlike Starship S-30, this booster was not recovered intact. Performance-wise, the Super Heavy reached an altitude of 97 kilometers at T plus 3 minutes and 53 seconds and achieved a peak speed of 5,287 kilometers per hour at T plus 2 minutes and 35 seconds. Meanwhile, the Starship spacecraft continued its journey after stage separation, igniting 6 engines to propel itself into space. At T plus 7 minutes and 55 seconds, the vacuum engines shut down, followed by the sea-level engines at T plus 8 minutes and 27 seconds. Impressively, at T plus 37 minutes and 45 seconds, one of the sea-level engines successfully reignited in space. During re-entry at T plus 39 minutes and 12 seconds, the spacecraft began glowing with a distinctive pink hue as friction with the atmosphere intensified. Despite certain areas of the heat shield being deliberately removed, the ship sustained no visible damage. As Starship descended towards the ocean, its sea-level engines fired up again at T plus 1 hour 5 minutes and 9 seconds to slow its descent. With the help of gimbaling engines and aerodynamic flaps, it adjusted its orientation to an upright position and reduced speed significantly. Finally, it achieved a controlled landing, resting vertically on the water's surface. Camera footage revealed small fires persisting after touchdown, offering further insight into post-landing conditions. In terms of performance metrics, Starship reached a maximum altitude of 190 kilometers at T plus 20 minutes and 7 seconds and maintained that height for over 3 minutes until T plus 23 minutes and 50 seconds. It also achieved an incredible top speed of 26,495 kilometers per hour at T plus 8 minutes and 30 seconds. These milestones mark significant progress for SpaceX, demonstrating continued refinement in Starship's capabilities and paving the way for even more ambitious missions in the future. The recent changes and achievements in Flight 6 set the stage for exciting developments in the near future. First, with the Super Heavy booster landing in the Gulf of Mexico instead of being caught, it's likely SpaceX will conduct another test flight to master catching the booster before attempting to catch the Starship spacecraft next year. This hints at a possible Flight 7, which could mark the debut of the upgraded Starship V2. If this happens, it would be the 5th Starship flight this year, a remarkable and ambitious pace. Are you excited about the possibility of another launch? Second, the successful demonstration of re-entry with modifications to the heat shield suggests that future Starships will feature new systems designed to facilitate the catching process. While the heat shield did perform well, further upgrades are expected to ensure greater durability and reliability. Third, the aborted catch attempt highlights the need for improvements to the launch pad systems. SpaceX will likely refurbish and upgrade the launch and landing infrastructure, including the tower, orbital launch mount, and protective systems. Early completion and operational readiness of a new tower equipped with enhanced safety and efficiency features will be critical as missions grow increasingly complex. Flight 6 has once again proven to be a success, showcasing SpaceX's continuous innovation and opening new prospects for Starship's future. Let's celebrate this achievement. Leave F6 in the comments section to honor the incredible efforts of the SpaceX team. Don't forget to like, share the video, and subscribe to our channel to stay updated on SpaceX's groundbreaking journey. And for the last segment of today's episode, let's shift over to India's ambitious plans for lunar exploration and its long-term space strategy. India has announced its intention to construct a lunar space station by 2040, marking a major step in establishing a sustained presence beyond Earth. This station, set to orbit the moon, will serve as an outpost to support crewed lunar landings and facilitate scientific research. Astronauts will use the station to analyze samples collected from the moon, making it a crucial element in advancing lunar science and exploration. The timeline suggests that the lunar space station could be operational around the same time other nations are establishing bases on the moon, provided everything proceeds as planned. This bold endeavor is the culmination of India's three-phase lunar strategy. The first phase is already underway and focuses on deploying robotic missions to the moon. India has achieved initial success with the Chandrayaan-3 mission and plans to follow it up with Chandrayaan-4 in 2028. The Chandrayaan-4 mission is set to return 3 kilograms of samples from the moon's south pole, an area believed to be rich in water ice. India aims to accomplish this at minimal cost, showcasing its ability to execute efficient and innovative space missions. The second phase involves sending humans to the moon by 2040, positioning India as the third nation to achieve this milestone after the US and China. The final phase will be the preparation and construction of the lunar space station. This station is expected to share design similarities with India's planned Earth-orbiting space station, the Bharatiya Antariksh Station, or BAS. The first module of BAS, called BAS-1, received governmental approval in September and is slated for launch in 2028, the same year as Chandrayaan-4. Additional modules will follow, with the station projected to be fully operational by 2035. Building a station in lunar orbit, however, presents unique challenges, far more complex than constructing one in Earth orbit. The harsh lunar environment, communication delays, and logistical hurdles will require innovative solutions. Despite these obstacles, India's determination and progress are commendable. Adding to its efforts, India plans to send an astronaut to the International Space Station next year for training and research, further strengthening its capabilities in human spaceflight. As India takes these bold steps toward the moon, the world eagerly watches to see how this emerging space power shapes the future of lunar exploration. Flight 6 marked another milestone in SpaceX's journey toward revolutionizing spaceflight, with both the Super Heavy booster and Starship upper stage achieving controlled vertical landings. However, the mission fell short of its loftier goals, including a ship catch, and surprisingly, a Super Heavy catch attempt was absent. Despite these omissions, the successful landings are a critical step towards SpaceX's overarching objective, developing a fully reusable rocket system capable of drastically reducing the cost of access to space. Central to this ambitious effort is the goal of catching the Starship upper stage, or ship, using the Mechazilla tower arms. Following the successful ocean landing of Ship 31, or S-31, SpaceX's CEO Elon Musk took to social media to announce the mission's success. Successful ocean landing of Starship. We will do one more ocean landing of the ship. If that goes well, then SpaceX will attempt to catch the ship with the tower. This statement underscores SpaceX's methodical approach to testing and development, prioritizing incremental progress toward achieving one of the most challenging aspects of Starship's reusability. Musk also hinted that this highly anticipated milestone could occur early next year, adding excitement to the company's future plans. The upcoming Flight 7 will play a pivotal role in SpaceX's testing program. This mission is expected to showcase Starship V2, the next iteration of the spacecraft, featuring significant upgrades to its heat shield and flaps. Rather than pushing for a catch attempt, SpaceX plans to conduct another controlled ocean landing. This cautious strategy allows engineers to validate the new hardware under the extreme conditions of atmospheric re-entry, without introducing the added complexity of catching the ship. Such a step is essential for ensuring safety, gathering valuable data, and refining the design before moving forward. While the lack of a catch attempt might seem like a setback to some, Flight 7 still promises plenty of excitement. If it launches before the year's end, it'll be the 5th Starship flight of 2024, a remarkable achievement considering the program's relatively slow pace last year. Preparations for the mission are already well underway. Ship 33 has completed cryogenic testing and is now being outfitted with engines for static fire tests. Meanwhile, the booster for the mission, likely Booster 14 or Booster 15, is progressing steadily toward readiness. On the regulatory front, FAA approvals are expected to follow the streamlined processes established for earlier flights, supported by ongoing reforms within the agency. Looking ahead, Flight 8 could be the mission that finally attempts to catch the ship. Scheduled as the second Starship V2 flight, this mission could take place as early as January or February next year, assuming all goes well with Flight 7. With Launchpad B operational, and SpaceX's Raptor engine reliability steadily improving, the prospect of witnessing the first ship-catching attempt feels tantalizingly close. Just a few months away, achieving this milestone would mark a turning point for the Starship program, bringing SpaceX closer to realizing its vision of fully reusable spaceflight. The potential of Starship goes far beyond catching its stages. This groundbreaking vehicle is designed to revolutionize space exploration and commercial spaceflight, with applications ranging from deploying massive satellite constellations to transporting humans and cargo to the Moon, Mars, and beyond. Its reusability and capacity to carry large payloads make it a game changer for reducing the costs and expanding the possibilities of space travel. SpaceX's meticulous approach to development underscores the complexity and ambition of its goals. Each flight builds on the lessons learned from its predecessors, inching closer to redefining what humanity can achieve in space. While setbacks and cautious testing are part of the journey, the rapid progress of the Starship program continues to captivate space enthusiasts worldwide. Are you ready to witness the first ship catch? Share your predictions and join the conversation by saying, "Let's do it," in the comments. Don't forget to like, share, and subscribe for more updates as SpaceX continues to push the boundaries of innovation and space exploration. The countdown to the next chapter in this groundbreaking journey has already begun. Looking ahead, the task of catching the ship holds immense significance for SpaceX's vision of full reusability. Achieving this milestone will accelerate Starship's launch cadence and drastically lower costs. As Shotwell recently announced, SpaceX aims to conduct up to 400 Starship flights over the next 4 years, a goal heavily reliant on the success of this reusability initiative. Catching ship will also pave the way for groundbreaking missions such as the development of an orbital refilling system. Musk emphasized the importance of this innovation, stating, "A fully reusable rocket with orbital refilling is the critical breakthrough needed to make life multiplanetary. The system's construction is expected to begin as early as March next year and will play a crucial role in the Artemis program's mission to return humans to the Moon by 2026. Beyond the Moon, SpaceX's ambitions extend further. Musk's response to Bill Nelson's congratulatory tweet, "To the Moon and beyond," underscores the larger vision. After mastering the ship catch, SpaceX plans to build the Starship HLS, conduct an uncrewed mission to the Moon by early 2026, and launch a crewed mission shortly after. Musk also hopes to send an uncrewed mission to Mars within 2 years, and follow it with a human mission in the next 4 years, all dependent on achieving full reusability. However, there's much work ahead to realize these goals. The issues with the launch tower that led to the aborted ship catch attempt must be addressed, necessitating significant upgrades to both the tower and the orbital launch mount. Catching Super Heavy successfully on the next flight will be a critical prerequisite for advancing to ship catching attempts. In the immediate term, SpaceX needs to analyze the data from Flight 6 and apply it to Flight 7's hardware upgrades. This flight will mark the debut of the Starship V2, and careful adjustments will be essential, particularly in overcoming challenges like developing a fully reusable heat shield, which Musk has identified as a major technical hurdle. Preparations for Flight 7 are already underway. The mission will likely include catching Super Heavy with the Mechazilla arm for the second time while performing another controlled vertical landing for the ship. This success will set the stage for catching both stages in subsequent flights. Additionally, the completion of Launchpad B, expected by January, will provide critical support for handling the increasing launch cadence and catching operations. The coming months, particularly Flight 7, will be pivotal in SpaceX's journey toward catching both stages of Starship. Let's stay tuned and see how SpaceX rises to meet these challenges. And now, let's turn to an exciting update regarding Hera, the payload launched aboard the Falcon 9 during last month's return to flight mission. Hera, part of ESA's ambitious asteroid study program, has reached a significant milestone on its journey to investigate NASA's asteroid impact experiment. According to ESA, Hera recently performed a series of crucial orbital adjustments. On November 6th, the spacecraft conducted a 13-minute burn, following an earlier 1 hour and 40-minute burn on October 23rd. Francesco Castellini from ESA's Flight Dynamics team remarked, "We are now analyzing Hera's new trajectory following the second burn. It appears to have gone very well." He also noted that a minor trajectory correction maneuver, mere tens of centimeters, is planned for November 21st to ensure Hera's precision for its upcoming Mars flyby. These adjustments have significantly boosted Hera's velocity. The second burn added 20 meters per second to its speed, building on the 146 meters per second from the first burn. With a total velocity increase of 166 meters per second, Hera is now set to reach Mars by March of 2025, leveraging the planet's gravity to reach its target, the asteroid Didymos, in 2026. Didymos and its companion Dimorphos hold particular scientific interest. Dimorphos was famously struck by NASA's DART mission in September of 2022 in a groundbreaking asteroid deflection experiment. Hera will follow up by assessing the long-term impact of DART's deflection on Dimorphos, providing critical data on asteroid redirection techniques. This research is essential for planetary defense, potentially offering solutions to protect Earth from hazardous asteroid impacts in the future, akin to the event that caused the extinction of the dinosaurs. Adding to its accomplishments, Hera has already captured and sent back its first images of Earth and the Moon. Though these were thermal images and the celestial bodies appeared as small dots due to the vast distance, the data is an encouraging start for further exploration. Hera's mission is particularly notable as it was launched under challenging circumstances on October 7th during a period of regulatory delays for Falcon 9. Thanks to SpaceX's expertise, the mission succeeded and Hera is performing exceptionally well. Stay tuned for more updates on this fascinating journey as Hera continues its path toward unlocking the secrets of asteroid redirection and deep space exploration. Attention! I know all eyes are on Flight 6 right now, but I'm here to tell you a major milestone is on the horizon. In Flight 7, we'll witness the debut of the next generation of Starship V2. SpaceX has confirmed it, and now the question is, will it launch this year? While we were still captivated by the excitement of Flight 5, SpaceX recently announced the launch date, timeline, and key updates for Flight 6. But at the end of this announcement, SpaceX included an equally intriguing teaser about Flight 7 and a new Starship version, V2. In their statement, SpaceX hinted at the upcoming changes, saying, "Future ships starting with the vehicle planned for the 7th flight test will fly with significant upgrades, including redesigned forward flaps, larger propellant tanks, and the latest generation tiles and secondary thermal protection layers as we continue to iterate towards a fully reusable heat shield." Although they didn't directly refer to it as V2, the details strongly suggest it. First, let's look at the redesigned forward flaps, a defining feature of V2 compared to V1. After the flap damage observed in Flight 4, SpaceX outlined several changes, including smaller, sharper flaps. The joint connecting the flap to the ship has been streamlined, and the forward flap will be positioned closer to the nose and leeward side of the ship. These changes aim to enhance flap control during navigation and reduce stress and impact during re-entry. Next, images of S-33, the first version of V2, reveal a slightly larger ship body, with the payload door positioned higher, indicating an increase in fuel tank capacity. This expansion is crucial for Starship's operational range, allowing it to carry more fuel to return to Starbase, support orbital refueling operations, and eventually venture beyond Earth orbit. Finally, significant upgrades to the heat shield will also be featured. Following Flight 4, SpaceX introduced a series of heat shield improvements, starting with S-30. This includes new, more durable tiles, potentially made of an enhanced material that will increase resilience and move closer to full reusability. Given the thousands of tiles needed per flight, reusability is essential for lowering production demands. Additionally, the heat shield is backed by secondary protective layers known as ablative layers, which provide added durability and comprehensive protection for the ship. With all these upgrades, Starship V2 represents a major leap forward toward full reusability and extended mission capabilities. These upgrades are pivotal, with SpaceX highlighting their importance in the recent update. Learnings from this and subsequent flight tests will continue to make the entire Starship system more reliable as we close in on full and rapid reusability. In short, all signs point to Starship V2 taking center stage. This also implies that the final version of V1, Ship 32, won't be making its flight debut. I initially expected S-32 would be featured in Flight 7, with V2's debut in Flight 8, but it seems clear that the S-32 hasn't undergone any testing since its completion, signaling its retirement. The likely candidate for Flight 7 is the V2 prototype Ship 33. After being assembled in a record 41 days, S-33 reached the Massey test site in late October for cryogenic testing. Following this, it returned to the production site at Mega Bay 2, where it received its engines. For now, it's equipped with Raptor 2 engines, though I expect that Raptor 3 will eventually be integrated, especially considering V2's expected liftoff thrust of 8,240 tons, a figure Raptor 2 cannot achieve. This makes Raptor 3 development crucial for V2's inaugural mission. If all goes smoothly, S-33 will soon head back to Massey for a static fire test. Once that phase is complete, it'll be ready to pair with a booster for integration testing. And now the question remains, which booster will fly alongside S-33? B-14, a V1 booster, completed cryogenic testing in early October and only needs static fire testing before it's ready for integration. Alternatively, B-15, seemingly stacked in July alongside S-33, could be a match. B-15 remains behind closed doors in Mega Bay 1 with no visible signs of testing yet. So, what are your thoughts? Will B-14, with its advanced progress but older version, take the flight, or will B-15, unpredictable but aligned with V2, be the choice? Let's speculate in the comments. SpaceX's choice regarding the booster for S-33 will be critical as it impacts the timing of Flight 7. If they opt for B-14, there's a higher chance Flight 7 could be launched by the end of this year. However, if they go with B-15, with its slower development, the timeline becomes less certain. The mission profile of Flight 7 will also play a role. Elon Musk mentioned that SpaceX aims to catch the ship next year. If they intend for Flight 7 to attempt this catch, the mission may shift to next year. However, if SpaceX wants the launch to happen this year, the first V2 prototype will likely still land in the ocean. Personally, I'd prefer to see the prototype land more conservatively in the ocean rather than attempting an immediate catch. With 5 Starship flights this year, am I being overly optimistic? What do you think? Let me know your thoughts in the comments section down below. Regardless, one thing is certain. V2 will take flight in Flight 7. Type F7V2 in the comments to mark this exciting milestone, and don't forget to like, share, and subscribe to stay up to date with SpaceX's journey. Now, on to NASA's recent update regarding the health of the Crew 8 astronauts. NASA has provided limited information about the recent hospitalization of a Crew 8 astronaut following the crew's return to Earth after an extended mission aboard the ISS. On October 25th, NASA revealed that an unidentified astronaut had experienced a health concern, prompting medical staff to transport them to Ascension Sacred Heart Pensacola Hospital in Florida. Although all 4 crew members were evaluated at the hospital, only 3 were cleared and returned to Johnson Space Center immediately, while the affected astronauts stayed behind for further observation. In an update on October 26th, NASA confirmed that the astronaut had been released the following day and had rejoined their fellow crew members at Johnson Space Center. They reported that the astronaut was in good health and ready to resume standard post-flight reconditioning protocols. While NASA refrained from disclosing the astronaut's identity or specific medical details to protect their privacy, they assured the public that the crew member's condition was stable and did not pose an ongoing concern. This situation shines a light on the unique physical and medical challenges faced by astronauts after long-duration spaceflights. Spaceflight impacts the human body in ways still not fully understood, and each mission provides new insights into how microgravity, radiation exposure, and prolonged confinement affect astronaut health. Crew 8's mission lasted an impressive 235 days, well over the standard 6-month duration for ISS rotations, exposing them to extended periods of these stressors. This extended mission time may have been a factor in the astronauts' health concern, though no details on this have been confirmed by NASA. At a press briefing, Crew 8 member Michael Barrett acknowledged the unexpected challenges that can arise in human spaceflight, stating, "Spaceflight is still something we don't fully understand. We're finding things that we don't expect sometimes." He indicated that this incident was an example of those unexpected factors, and expressed NASA's commitment to respecting the astronauts' privacy while continuing to assess and understand the situation. Barrett also hinted that NASA may reveal additional information about the incident after their internal review concludes. The incident emphasizes the rigor of NASA's post-flight protocols, especially following such a lengthy mission, and highlights the agency's commitment to astronaut health. The post-flight reconditioning period involves thorough monitoring and physical recovery sessions to help astronauts readjust to Earth's gravity, address any health complications, and ensure they are ready for future missions. As the Crew 8 astronauts now undergo reconditioning, the incident also serves as a reminder of the importance of health and safety advancements as humanity aims for more ambitious missions to the Moon, Mars, and beyond. With each mission, NASA gains valuable data on the impacts of space travel on the human body, helping to refine procedures and support astronaut health on longer journeys to more distant destinations. The dedication of Crew 8, who contributed significantly to the ISS operations over their 235 days in orbit, underscores the resilience and adaptability required for space exploration. Now, turning to Europe for an update on the Ariane 6, specifically its second flight. After the inaugural Ariane 6 mission this July, Arianespace has announced there won't be additional launches for the remainder of the year. Additionally, a follow-up launch was set for December, but it has now been postponed to mid-February, aiming for early in the month. This second mission under Arianespace's direction will involve deploying the CSO-3 reconnaissance satellite for the French military, marking a significant step for the Ariane 6 program as it begins fulfilling defense-related objectives. Despite the challenges encountered during the first mission, including an issue where the upper stage's auxiliary power unit, or APU, failed to activate due to an out-of-limit temperature reading, ESA and Arianespace remain confident in the upcoming schedule. Engineers identified the problem as a software-related oversight affecting the APU's sequence before the final deorbit burn, an issue they have since resolved. Arianespace has clarified that these were not critical hardware issues, reinforcing that the fix has been thoroughly tested and implemented. The Ariane 6 hardware is expected to arrive soon at the launch site in French Guiana, where it will undergo preparation for the February flight. Alongside the Vega C's anticipated return to flight mission on December 3rd, this milestone underscores Arianespace's plans to build momentum in the coming months. The company is setting high expectations, aiming to conduct 6 Ariane 6 launches next year, a target that, if met, would demonstrate both reliability and an increased cadence in their launch schedule. It's a bold move, and only time will tell if Arianespace can meet this ambitious launch rate for 2025, especially as they establish Ariane 6 as a reliable option in the competitive global launch market. Are you optimistic that Arianespace can reach this goal and carve out a more substantial presence in the industry next year? 5 weeks. That's the remarkable turnaround time between Flight 5 and Flight 6. But achieving this milestone wasn't just about technical progress. It's a testament to the evolution of every prior mission. However, even with all the advancements, success would be unattainable without navigating the challenges posed by regulatory bodies like the FAA and others. That's where Gwynne Shotwell's leadership shines. Her ability to maintain strong, cooperative relationships between SpaceX and key agencies has been instrumental in keeping the momentum alive. In the future, it promises even more frequent launches as SpaceX pushes boundaries further. Later, we'll also explore NASA's latest steps with the Orion spacecraft for the Artemis II mission. Recently, on X, I came across some striking statistics about Starship's turnaround time, revealing an impressive 36 days between Flight 5 and the upcoming Flight 6. When compared to the 129 days between Flight 4 and Flight 5, the difference is staggering. It's worth noting that the gap between Flights 4 and 5 could have been even longer if the FAA had enforced its earlier delays, pushing Flight 5 to late November. Without that resolution, we wouldn't even have seen Flight 5 by now. So what's driving Starship's dramatic improvement in turnaround time? Many might credit Elon Musk for his outspoken criticisms on X and in the media targeting agencies that have impeded SpaceX's progress. While this approach garners attention, it often increases tension rather than fostering solutions. In such circumstances, SpaceX requires a diplomatic leader who can effectively negotiate while maintaining strong relationships with regulatory agencies. And Gwynne Shotwell has proven to be that leader time and time again. Take last month, for example. Shotwell addressed the Texas House of Representatives, where she tackled issues stemming from conflicts between SpaceX and the Texas Commission on Environmental Quality, or TSEC. Notably, she refuted the TSEC's claim that SpaceX had improperly used its water deluge system. Shortly after, TSEC acknowledged their error. Shotwell has consistently emphasized SpaceX's compliance with federal laws and its commitment to resolving challenges after each flight. Examples of this include the installation of the water-cooled steel plate beneath the orbital launch mount following the crater incident during Flight 1, the implementation of hot staging to improve stage separation, and upgrades to both engines and heat shields. These improvements culminated in Starship's remarkable milestones: a successful Super Heavy landing with Mechazilla's arm and a controlled vertical landing of the ship. In her testimony, Shotwell also urged federal and state governments to modernize regulatory frameworks, cautioning that outdated systems could stifle innovation, particularly in aerospace. She further stressed the importance of Starship to NASA's Artemis program, positioning it as a critical asset for the U.S. in maintaining its leadership in space exploration against growing competition from China. This argument is particularly relevant given the challenges NASA faces with cost overruns, delays, and inefficiencies in its own systems. Shotwell's reputation has earned her praise from key figures, including NASA Administrator Bill Nelson, who commended her leadership.
Elon has a president that he lets run the company, and her name is Gwen Shotwell.
Nelson remarked. I hugged her with a smile on my face because I know she is running that thing. She's running SpaceX, he added. Thanks to Shotwell's leadership and her team's efforts, the Flight 6 schedule was made possible just 36 days after Flight 5, a record-breaking turnaround for Starship. This pace is 3.5 times faster than the gap between Flights 4 and 5, an achievement unmatched by any organization in aerospace history. What Shotwell has accomplished signals a new era for the industry. Let's honor her remarkable contributions. Comment Gwen Shotwell below to show your appreciation. And don't forget to like, share, and subscribe to our channel as we continue to follow SpaceX's incredible journey. Gwen Shotwell's influence is not only shaping Starship's present success, but will undoubtedly leave a lasting impact on its future. With Flight 6, SpaceX is on track to achieve 4 Starship launches this year, an improvement over 2023. However, this number remains modest compared to the ambitious goals set by Elon Musk and SpaceX. One such goal, the proposal to launch 25 Starships annually from Starbase, was initially postponed by the FAA following disputes with environmental agencies. Encouragingly, Kathy Lueders recently revisited this plan, crediting it to Musk. It's likely we'll see this ambitious target reinstated as early as next year. Achieving such milestones will require more than just internal efforts. It demands regulatory reforms. Shotwell's ability to navigate complex relationships with agencies like the FAA will play a crucial role in expediting those changes. A reformed FAA would pave the way for SpaceX to accelerate operations in 2024 and 2025, a critical time frame for Artemis program preparations. This is just the beginning for Starbase. According to a NASA official, SpaceX could shift operations to Florida if the company achieves a cadence of 1 launch per week at Starbase, amounting to over 50 launches annually. If this happens, it's plausible SpaceX could hit that milestone by early 2026. Shotwell's leadership will be instrumental in reaching such operational efficiency. Florida represents the next frontier. SpaceX has long-term goals to launch 44 Starships annually from the state, likely in support of NASA's Artemis program. However, progress on this front has been slow. Strong collaboration between Shotwell and NASA will be key to unlocking these opportunities, bringing Starship closer to operating from the aerospace industry's holy land. With Artemis 3 just 2 years away, this will undoubtedly be one of Shotwell's most critical tasks. Looking further ahead, SpaceX's vision grows even more ambitious. According to Musk's Mars colonization plans, SpaceX aims to launch 10 Starships per day during Mars transfer windows, amounting to thousands of launches annually. Reaching such extraordinary goals will require not only Starship's rapid reusability, but also a robust network of launch pads and support systems. Expanding launch facilities, however, poses its own challenges, especially when dealing with environmental concerns. A recent example is the now abandoned land exchange proposal between SpaceX and the Texas Parks and Wildlife Commission. While this plan was shelved, future expansions will undoubtedly require similar negotiations. Shotwell's expertise in navigating these sensitive relationships will be vital in overcoming such hurdles and enabling SpaceX to scale its Starship operations. In every scenario, Gwen Shotwell has consistently demonstrated her unparalleled value to SpaceX's development. Her leadership has been pivotal, and Elon Musk's decision to make her a key partner in SpaceX may well be his greatest move since founding the company. Together, these two leaders are poised to guide SpaceX into a new era of innovation and achievement. The future is brighter than ever. Let's see how Shotwell and Musk lead SpaceX to new heights in the years to come. To wrap up this episode, let's turn to an update on the Orion spacecraft and the Artemis II mission. After much skepticism, NASA has taken a significant step closer to the first crewed flight of Artemis II, currently scheduled for September of 2025. On November 6th, Orion was moved into an altitude chamber within the Neil Armstrong Operations and Checkout Building at NASA's Kennedy Space Center. According to a NASA update on November 12th, engineers have returned the spacecraft to the chamber, which replicates the vacuum conditions of deep space to complete critical testing. These tests are designed to validate data collected earlier this summer and ensure the spacecraft can withstand space-like conditions in preparation for its upcoming mission. Next year's Artemis II mission will send 4 astronauts on a 10-day journey around the moon. This milestone will mark the closest human approach to the moon since the Apollo 17 astronauts set foot there over 50 years ago. If successful, Artemis II will set the stage for Artemis III, the highly anticipated lunar landing mission scheduled for the following year. However, despite this recent progress, significant challenges remain for NASA. The Orion spacecraft has been plagued by technical issues, most notably the heat shield damage discovered nearly 2 years ago. NASA has yet to publicly disclose the root cause of the problem, fueling skepticism about the spacecraft's readiness. Moreover, it remains uncertain whether NASA will stick with the existing design, which carries known risks, or implement a redesigned heat shield, a decision that could introduce delays. Adding to the uncertainty, the Space Launch System, Orion's launch vehicle, continues to face significant cost overruns and schedule delays. With less than a year remaining until the September 2025 launch window, even minor setbacks could jeopardize the mission timeline. These persistent issues have led to growing calls from experts, organizations, and media outlets to reevaluate the SLS and other NASA systems within the Artemis program. Some have even proposed canceling the SLS in favor of more cost-effective and efficient alternatives. For NASA to solidify its position and salvage the Artemis program's future, decisive action is needed. Without stronger, more consistent progress, the viability of NASA's current systems could be in serious jeopardy. The agency must act swiftly to address these challenges, or risk losing the momentum of its ambitious lunar exploration goals. The clock is ticking, and NASA's next steps will determine whether it can rise to the occasion or face an uncertain future for its flagship missions. Cancel the SLS. That's right, I said it. And honestly, this phrase is no longer just a sentiment shared by aerospace enthusiasts. It's now a rallying cry echoed by prominent agencies, influential figures, and major publications. Even the U.S. Space Force has voiced concerns. The end of NASA's space launch system may be closer than ever. Amid this shift, SpaceX's Starship, with its rapid progress and impressive capabilities, is emerging as the key to sustaining the Artemis program. So what are these agencies and publications saying about the SLS? And what might Artemis look like without NASA's flagship vehicle? As the launch of Artemis II approaches in less than a year, questions around NASA's readiness and program costs are intensifying. The Artemis program, while ambitious in its vision to return astronauts to the moon, has been bogged down by skyrocketing expenses and lengthy delays. Artemis I alone required nearly a decade and tens of billions of US dollars to complete, a troubling precedent as NASA gears up for the next phases. The Space Launch System, intended as NASA's flagship rocket for lunar missions, has become an emblem of these inefficiencies, burdening the program with its high costs and extensive infrastructure needs. Since its inception, SLS has been under scrutiny for its enormous cost, complexity, and limited launch capabilities. Developed in conjunction with the Orion spacecraft, mobile launch systems, and proposed lunar gateway, the SLS is envisioned as the backbone of the Artemis program. However, even some of NASA's closest partners are now questioning the value and necessity of this colossal system. Recently, Colonel Douglas Pentecost of the U.S. Space Force expressed doubts about the SLS's relevance for defense or commercial purposes, noting, "It's a capability right now that we, the DoD, don't need." His remarks suggest that within the Department of Defense, there's little interest in leveraging the SLS for missions due to the availability of more cost-effective alternatives. Christina Chaplin, former assistant director at the Government Accountability Office, has voiced similar concerns. She highlighted SLS's production inefficiencies, stating, "I don't see the cost going down at this point to be competitive." Chaplin pointed out that the SLS lacks the streamlined factory-style production of private sector rockets, resulting in cost overruns with little chance of economic improvement. Without the manufacturing efficiency seen in companies like SpaceX, SLS's financial sustainability remains dubious. The question of SLS's future viability has led to speculation about whether it should continue. Space journalist Eric Berger has even suggested there's a 50-50 chance that SLS will be canceled, arguing that there are other ways to get Orion to the moon. This sentiment is shared by media mogul Michael Bloomberg, who recently criticized the Artemis program's financial approach. Bloomberg argued that SLS is a colossal waste of taxpayer money, with its cost structure including $23 billion for development and $4 billion per launch, outstripping NASA's initial projections. One of Bloomberg's most pointed criticisms is that even if the SLS does become fully operational, it isn't capable of delivering humans to the moon independently. In his words, it isn't even powerful enough to actually get anyone to the moon, at least not in its current configuration. This forces NASA to rely on additional components, such as the Starship human landing system by SpaceX, to complete the lunar mission. Furthermore, the SLS's costs are exacerbated by other infrastructure expenses, including the ML2 mobile launcher, which has ballooned from an initial estimate of $250 million to $2.7 billion. The SLS's Orion module has encountered issues, returning from Artemis 1 with a damaged heat shield that has set NASA engineers back as they scramble to resolve the problem. This, coupled with delays on the Lunar Gateway and uncertainties surrounding the upgraded SLS Block 1B variant, adds another layer of concern. The Lunar Gateway, which NASA intends as a staging point for lunar operations, has faced criticism for its high complexity and its questionable compatibility with SpaceX's Starship HLS, the very spacecraft designed to transport astronauts from the Gateway to the moon's surface. The ML2 mobile launcher, initially envisioned as a straightforward solution for the SLS, has spiraled in cost, currently totaling around $2.7 billion with no firm completion date. Its contract has logged over 850,000 overtime hours over the past 2 years, reflecting just how intricate and time-consuming the process has been. These accumulated setbacks and cost overruns are taking a toll on NASA's timeline and budget, further delaying Artemis's objectives and risking public confidence in the program. In sharp contrast to SLS's limitations, SpaceX's Starship presents a more streamlined and cost-effective path to the moon. Unlike the SLS, which is expendable, Starship is fully reusable, promising substantial cost savings and faster turnaround times. Its ambitious design allows for in-orbit refueling, enabling long-distance lunar missions without the need for extensive, expensive support infrastructures like the Lunar Gateway. With rapid advancements in testing and development, Starship is set to potentially redefine human spaceflight. SpaceX has made significant strides in recovering and launching its Super Heavy booster using the Mechazilla system, a revolutionary setup that will support Starship's mission cadence. Recent developments in Starship's vertical landing and payload capabilities suggest that it may be ready for lunar operations by 2026, aligning with NASA's planned Artemis missions. Bloomberg summarized Starship's potential succinctly, stating, "A reusable SpaceX Starship will very likely be able to carry cargo and robots directly to the moon, no SLS Orion Gateway Block 1B or ML2 required, at a small fraction of the cost." With this in mind, Starship offers a compelling alternative to SLS, particularly as NASA faces growing pressure to find more financially sustainable approaches. The challenges facing SLS underscore a need for NASA to reconsider its approach to the Artemis program. Given the substantial investments and limited flexibility of the SLS, it may be time for NASA to lean more heavily on private sector solutions, specifically those offered by SpaceX. Utilizing Starship as a primary launch vehicle could streamline Artemis's goals, cutting down on expenses and eliminating unnecessary logistical components like the Gateway. Embracing a partnership with SpaceX and leveraging Starship's capabilities would enable NASA to achieve its lunar objectives faster and more cost-effectively. This approach would allow Artemis to focus more on resources on mission-critical technologies rather than maintaining a high-cost infrastructure centered around the SLS. As NASA faces the dual pressures of rising costs and increased expectations, a shift in strategy may be essential. The decision to keep SLS or replace it with commercially available options like Starship could ultimately determine the long-term success of Artemis. If you agree that NASA should streamline Artemis by adopting more efficient technologies, show your support by commenting "Scrap Launch System" and share this update to spread awareness of SpaceX's exciting journey toward making lunar missions more accessible and sustainable. Indeed, if NASA's SLS and associated systems are removed from the Artemis program, the program would undergo significant transformation. The first major shift would likely be the end of the two-rocket launch approach. Instead, a single rocket would carry the crew to the moon, facilitate landing, and then lift off from the lunar surface to return home. This all-in-one vehicle would be none other than SpaceX's Starship HLS. It's a streamlined approach that arguably should have been the plan from the get-go. For Starship HLS to carry out these tasks, certain upgrades would be necessary to optimize crew transport from launch. If tasked with bringing the crew back to Earth, the HLS would need additional features, such as heat shields and flaps for safe re-entry. Currently, SpaceX is refining the landing process for Starship, and they have over a year to fully master it before Artemis 3. Following this, any necessary design adjustments can be made to further optimize the spacecraft. Alternatively, if SpaceX prefers to minimize changes and maximize reliability, they could substitute NASA's system with their own Falcon and Dragon vehicles, possibly involving a Falcon Heavy. In this scenario, Falcon Heavy could launch a Dragon capsule with the crew, rendezvous with the Starship in lunar orbit, transfer the crew, and then wait in orbit to retrieve them for the journey home, essentially following NASA's existing process, but with SpaceX's more cost-effective technology. A third option could see Starship completing the entire journey to and from the moon, bringing the crew back to Earth orbit, where they would then transfer to a waiting Dragon capsule for re-entry and landing. Each of these options avoids reliance on NASA's vehicles and would likely be more feasible and reliable than the current setup. If NASA is genuinely considering canceling the SLS, a swift decision is essential. We're nearing the end of 2024 with less than a year remaining before Artemis 2 and under 2 years for Artemis 3. Early preparation is critical. Even with SpaceX's rapid progress, late decisions from NASA could prevent timely design or operational changes, causing delays. Delays could impact the US's position in the lunar race as China also accelerates its lunar ambitions. Ultimately, the decisions rest with NASA, an organization once at the forefront of lunar exploration, but now facing challenges due to inefficiency. NASA will oversee and manage the program while SpaceX handles the mission's execution. This approach could be the key to the US regaining its lead in lunar exploration. What are your thoughts on the matter? Feel free to share your perspective in the comments section down below. Exciting developments are unfolding in the world of space exploration. After a long wait since the demolition, we're finally seeing the first steps toward building the new orbital launch mount system in Florida, with fresh details now revealed about its construction. What can we expect from its design and structure? In other news, Rocket Lab has just launched another Electron mission, adding to an impressive launch record this year. According to the Artemis roadmap, it's clear that SpaceX's Starship will eventually launch from Florida. Recently, NASA shared new insights on when Starship operations in Florida might begin. But regardless of the timeline, the necessary launch infrastructure must be completed soon. This setup will likely resemble Launchpad B at Starbase, which has been advancing swiftly. Signs of the Florida system's development began months ago when SpaceX dismantled the orbital launch mount legs at Cape Canaveral. This was further underscored by the FAA's environmental impact statement for Starship operations in Florida, which included a conceptual diagram of the planned launch system. Now, the first tangible steps toward this launch pad, specifically the OLM, have commenced. New images from the National Oceanic and Atmospheric Administration reveal early hardware in an area known as Hangar M. These parts, likely components of the water-cooled system, are still arriving in smaller pieces, indicating that full assembly is yet to come. Notably, these components bear a striking resemblance to those used for Pad B at Starbase, suggesting a similar structural design. It appears the Florida launch system will feature an updated OLM along with a distinctive flame trench system beneath it. This trench may have a unique configuration with 2 flame buckets on either side, as discussed in a previous episode. With these developments, the construction of Florida's OLM is expected to proceed in parallel with Launchpad B at Starbase. Given that Pad B began earlier, with completion targeted for January, the Florida system will likely follow shortly, possibly by February of next year. This is a crucial step toward next year's ambitious goals. SpaceX is set to begin constructing its in-space refueling system in March, likely starting at Starbase, with the Florida launch system taking on a greater role as development progresses. NASA recently shared that Starship operations will shift to Florida once the launch cadence at Starbase reaches 1 flight per week, projected for late 2025 or early 2026. Completing the Florida launch system on schedule is essential to supporting this timeline. In addition, the Florida pad will likely serve as the future launch site for Starship HLS, making early completion and rigorous testing critical for ensuring the system's reliability before any official mission. With this new launch pad design in Florida nearing completion, excitement is building. If you're just as eager, drop a 1 in the comments section down below. Then be sure to like, share, and subscribe to stay updated on SpaceX's progress. As noted, the Florida OLM system and Pad B at Starbase feature new designs introducing changes in the construction process. Recently, a 3D artist known as O, specializing in visualizations of Starship and Starbase, shared a detailed animation of this new setup. Big thanks to O for his outstanding work. Be sure to follow him on X to encourage more of these creative insights. Now let's take a look at the video. Construction of the OLM starts with the assembly of the foundational legs. The system will feature 12 legs, 8 standard square legs, and 4 corner legs, with a specialized structure, each incorporating 4 smaller support legs. These 4 reinforced legs will anchor the corners, while the remaining 8 will be distributed along the sides, 2 on each side, forming a sturdy square frame as the foundation for the OLM. Following the assembly of the foundational legs, large steel plates with hollow designs will be mounted on top, creating the initial structure of the orbital launch mount. These plates are organized into 2 distinct types, referred to here as corner blocks and edge blocks. First, the 4 corner blocks will be positioned on the reinforced corner legs, followed by the placement of the edge blocks on the remaining standard legs. These blocks are designed to interlock, forming a cohesive frame. Smaller steel plates will then be added to secure and complete this foundational layer. Once the first frame is in place, a second, larger frame will be installed. Like the initial frame, it includes both corner and edge blocks, which will be assembled in a sequential process. First, the corner blocks will be positioned, followed by the edge blocks, and finally, additional steel plates will be added to tie the structure together. Next, a series of steel plates will cover this upper frame, forming a closed structure for the OLM. These cover plates will consist of 2 rounds, an inner and an outer set, each with 8 plates. The inner plates will feature a specialized structure to accommodate a central circular opening, while the outer plates will have a simpler straight design. These steps outline the basic construction sequence for SpaceX's new OLM. While the part names used here are unofficial, they help illustrate the process. If you have insight into official terminology, feel free to share them in the comments section down below. This streamlined assembly method means that as long as components are ready, the OLM construction can proceed swiftly, enabling SpaceX to construct multiple OLMs as needed. There's also speculation about potential upgrades, including a mobile feature for enhanced flexibility. Let's keep an eye out for developments on that front. In addition to the launch pad, SpaceX is set to build additional infrastructure in Florida to support Starship's upcoming operations. According to the environmental impact statement, plans include the construction of catch towers, deluge ponds, and tank farms. To sustain operations long term, it's likely SpaceX will need production facilities. While a full-scale star factory may not be feasible in Florida, alternative solutions could involve production tents, assembly bays, warehouses, offices, and operations buildings. These facilities will provide the foundation for Starship launches from the heart of the aerospace industry. Now, moving on to updates from Rocket Lab's latest Electron mission. At 5:56 a.m. Eastern Daylight Savings Time on November 5th, Rocket Lab launched an Electron mission for a confidential commercial customer. Dubbed Changes in Latitudes, Changes in Attitudes, this mission successfully delivered a commercial satellite to low Earth orbit. 9 minutes into the flight, the rocket's second stage separated, placing the payload into orbit. However, Rocket Lab did not livestream the deployment at the customer's request. Following the mission, Rocket Lab CEO Peter Beck confirmed the success, stating, "Payload deployed, 100% mission success." No additional details were provided about the payload itself. This mission marks Rocket Lab's 12th launch of the year and the 54th in its history. After tying its previous record of 10 launches in August, Rocket Lab surpassed it with its 11th mission in September, further extending its launch record with this latest flight. With 2 more missions expected this year, Rocket Lab is on track for a record-breaking launch cadence in 2024, positioning the company for even greater achievements in the years ahead. Next year, Rocket Lab's focus will extend beyond Electron to include its upcoming Neutron rocket, marking a significant step in the company's expansion into heavier payload capabilities. With promising progress already underway, Neutron is poised to add Rocket Lab as a competitive player in the space race. We'll be watching closely to see how Rocket Lab's innovations contribute to the evolving landscape. Now, let's move on to our final piece of news of this episode, an update on India's moon sample return mission plans. India is setting its sights on an ambitious lunar sample return mission, Chandrayaan 4, targeted for 2028. This mission aims to collect and bring back to Earth approximately 3 kilograms or 6.6 pounds of samples from the lunar South Pole, a region believed to contain valuable water ice deposits. ISRO Chairman S. Somanath remarked on the challenge, stating, "Of course, Americans and Russians have done it way back, but doing it today is still a huge challenge, and it is very expensive. We're looking at how we can do a mission to the moon and back in a low-cost manner." The mission architecture involves 5 spacecraft modules and will require 2 launches using ISRO's most powerful rocket, the LVM-3. In the first launch, a lander and a sample-collecting ascender vehicle will be sent to the moon, followed by a second launch carrying a transfer module and a re-entry module, which will remain in lunar orbit. Once samples are collected, the ascender will launch from the moon's surface to deliver its payload to the re-entry module, which will then return to Earth. In preparation for this mission, ISRO plans to conduct a $14 million space docking experiment, or SpaceX, later this year or in early 2025. This experiment will serve as a crucial test of in-space docking capabilities, which will be essential for transferring the lunar samples. Although the precise landing site for Chandrayaan 4 has yet to be confirmed, it is expected to be near Shiv Shakti Point, close to the successful landing site of Chandrayaan 3. Following the Chandrayaan 4 mission, India plans to collaborate with Japan on Chandrayaan 5, another exciting step in its lunar exploration roadmap. Additionally, India aims to send astronauts to the moon by 2040 with the ultimate goal of establishing a lunar base by 2050. These are indeed ambitious plans reflecting India's growing commitment to space exploration. While India's goals are admirable, the United States is likely to remain a leader in the space race, particularly with the advancements of SpaceX and Starship. The U.S. is on track to achieve key milestones, including a projected human landing on the moon as early as 2026. This progress would position the U.S. as a welcoming partner when astronauts from India eventually arrive, fostering a new era of international cooperation in lunar exploration. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.